Our next consideration will be the classification of variables based on their types. For variables, they can either be quantitative, otherwise called numerical variables, or they can be qualitative, otherwise called categorical variables. Examples of numerical variables would be account balance, weight, car speed, number of students in a class section, and so on and so forth. Take note that the values we record for each of these variables would necessarily be numbers. On the other hand, we talk about qualitative or categorical variables. These are variables for which their data values are not numbers, but they consist of what labels or descriptions. And so they are inherently very useful for grouping, hence the categorization and or ranking. Examples would be marital status of customers, of loan customers, and the credit rating of the customers. Other examples could be hair color, um, blood type, zip code, the car a person drives, and even nationality. These are all examples of qualitative or categorical variables. And to quickly check how well we understand this, how would you classify each of the following variables that have been defined below? One, the number of pairs of shoes that you own. What do you think? I think that would be numerical, also called quantitative. The type of car you drive, that would be qualitative or categorical. And where you go on vacation, what do you think? Categorical, I agree with you. Then the distance from your home to the nearest grocery store, that requires some numerical computation, and so it will be recorded numerically. So this is definitely numerical. I would say that the tuition for your classes will also be recorded as a numerical set of values. So when it comes to classification of variables based on type, we have quantitative and quantitative. Again, let me say that one more time. Quantitative and qualitative, or numerical and categorical. Let's look at numerical variables a little bit deeper. You see, when you record a number, let's say you have age, and let's say you have what? Cups of coffee that each person drank each week. Well, for one, we're definitely, and let me also look at height. For the purpose of simplicity, let me keep age out for now. And you notice that for cups, we need to count cups of coffee, maybe 4 this week, 3, 2, 4, thereabout. In each of these values, we're definitely counting to get each of those values. Whereas for height, we will need to be measuring. So depending on whether you count or measure to arrive at a numerical data value, we can classify numerical uh, variables as either discrete, if you're counting to get that value, or continuous numerical variable if you're measuring to get the value. So numerical variables can be either discrete or continuous in nature, depending on whether the numbers come from either a counting operation or a measuring process. Let's test our knowledge on this. So, the number of classes you take in a semester, what do you think? Do you count or do you measure? I would argue that we will be counting. So this is a discrete numerical variable. What about the weights of sumo wrestlers? Absolutely continuous because we're measuring. What about the distance you drive to school? I use a speedometer, and so to measure, and this is continuous. What about the amount of money one playing poker? If this is measured in chips, then we're counting all the way to the bank. So you have discrete. Let's proceed a little further to talk about data types based on levels of measurement. You see, if a variable is categorical, then it can either be at the nominal level of measurement, which is the lowest on the ladder of levels of measurement, or it can be at the ordinal level of measurement. What is the difference between the two? So take notes, a categorical variable, a categorical variable can either be at the nominal or ordinal levels of measurement. You see, at the nominal level of measurement, these are the lowest form of categorical variables. And it is only a level for only categorical data. It cannot be used for calculations, only for grouping. So if you collected data on names, it will be at the nominal level of measurement just for grouping. Yes or no responses, zip code, and so on. On the other hand, at the ordinal level of measurement, rank or order matters in addition to grouping. So there is a grouping of items at the top of the ladder and then those next in line and subsequently. They cannot be used in calculations, so think about the military rank. Think about how you rate a product on Amazon. Is it excellent, good, or unsatisfactory? There is an inherent preference or ordering structure. What about pay grade? So, whatever data values you get from this, they cannot be used in calculations, but they can be used in both grouping and ranking at the same time. Now, you see, for numerical variables, they can either be at the ratio or interval level of measurement. Interval is right here, right after ordinal, and ratio is at the top of the pile. You see, to distinguish between variables at ratio or interval level of measurement, I'm going to define a concept called absolute zero, or as I like to call it, I like to call it true zero. You see, if you look at the table in front of you and you count how many cars there are on that table, logically, there's zero cars on that table. So, zero cars means absence of a car on a table. That is a true zero. In other words, a true zero should reflect absence of that quantity, of any quantity. Take for instance, you see, if I said my account balance is $0, is this zero a true zero? Well, I would say yes, because if I have $0 in my account, I am absolutely broke. So this means absence of money. That is the behavior of true zero. Let me contrast that with if I recorded 0 degrees Fahrenheit for a particular city. Does this 0, does it mean absence of temperature? Absolutely not. That is not true. So this 0 in this case is not true 0. Temperature is therefore said to be at interval level of measurement, whereas account balance is at ratio level of measurement. So data collected on variables at interval level of measurement have no true or absolute zero or absolute zero. Whereas variables at ratio level of measurement has an absolute or true 0 point, and ratios can be calculated. It can also be used in calculations, but it's a level of only ratio data. And in particular, let's put that as of only numerical data. I meant to write that. Okay.